Hello, so we're back in this time. We have an insane job. So check here. Never seen something like that. So this is some kind of gaming tablet. It's a ASUS ROG. We have RTX graphics and i9. And I can't believe, check here. So here it's a screen with view to the motherboard. You can see the components there. Yeah. Crazy. For those who dare. Can we dare to repair something like that? No charge power, basically dead. Now, you'll be surprised from where this job is coming. From where do you think it's coming? From the same guy who sent the Alice. You remember the two consoles? Yeah. I hope you're having a lovely midsummer. Yeah, too hot for me. Thanks for the Ali X. I have for you ASUS ROG Flow Z13 2022. No charging, no powering on. Have disconnected, reconnected battery and no change. You see, a happy customer, it will always come back. So, not sure from where we should start with this. I'm assuming the keyboard is removable. Yeah, we can remove the keyboard. Yeah. Good, we don't need a keyboard. Hopefully I don't have to take the screen out because I'm not gonna take the screen out. We have fun here. Let's try to find some screws somewhere. Wait, here we have some stuff. Screws. Here. Here we have a screw. Not sure what is here. Memory card place. Here it's a M2 drive. And let's take the screws out. How you will charge something like that? Has USB-C, check there. And here we have the power button. Yeah, pressing the power button. Obviously nothing happened. Okay, let's open the tablet. I mean, I can't believe you can buy a gaming tablet with, with this kind of specs, which is insane. I mean, this is the future. So we're not gonna game on laptops. Here we have few screws. Let me check if I can find a video on YouTube about how we can open this tablet. Okay, that's a little bit crazy. So the screen is coming out. The screen with the frame. Yeah, not only the screen. So basically from here. I don't think I want to crack the screen on this tablet. Lol, so the screen is so thin. Check that. Check how the screen is moving. You can see it's flexible actually. Oh. And the screen is kind of out. Yeah, we do have ribbon cables here. So be sure you are taking the ribbon cables out. This one. And we have the screen ribbon cable, which is here. Yeah, let's disconnect the battery. Yeah, and the screen is out. Yes. Sharp screen. I didn't know how actually Sharp is doing screens. Interesting. Wow, so we have like a, like a proper gaming motherboard. Check here. Like nice heatsink. Check here, we have a seal. You can believe that? Yeah. So what we are checking first? Here we have a seal, so no one took out the battery or the heatsink. What we are checking first is the main power rail. Yeah. Like usual, like on any laptop. Same with the tablets. So the main power rail, you need a ground. Yeah, here it's a ground. And check here, yeah? You have coil, you have chip, you have capacitor. And here is fine, here is short. No, the main power rail is not shorted. No. Okay, let's plug a charger and see what it's doing. Yeah, it's good and bad. If it was like main power rail shorted, that's the only problem. But if that is not shorted, then we can have like a dead PD controller, like a dead DC chip. The meter is coming on. We have 19 volts. Wait a second, so what's the problem with this tablet then? Power button. Power button is here, pressing the power button. And the current is changing actually. Holding the power button down. I mean, not sure what should I say. Okay, let me connect the battery. Let me see if it's charging. Connecting the battery and nothing happened. What voltage do we have on the battery? So on the battery, we have like nothing. Okay. Battery has 2 cells. Okay. Power supply, little bit of current. Yeah, that should be fine. And we have ground, and we have plus, and we are charging the battery. And it's not charging. No. Wait, why the battery is not charging? Let me try like that, yeah? So we have ground. This is ground? It is. And this is plus. And it's not charging. No, nothing. Why is not charging? I mean, this is a new thing. A new device. How the battery can die so quickly? I don't even know what to say, because on these days you have laptops which they are not starting without a good battery. This is a battery issue or what? Why I cannot charge the battery? Oh lol, it's 15.5. I can't believe. So actually here are like 4 cells, not 2. That means the charging voltage should be like 16. Yeah. And nothing. No. Let me plug the charger. I mean, I'm a little bit slow because I never repair something like that, so we have to be careful. It's taking like 10 milliamps, I can see. I don't even know how much it's a battery for it. Probably it's expensive. So, I have some, some failings on, cutting the battery to check inside. Why the battery is not charging? You know what? Let's do something. Let's check the coils. Let's see the coils. So this one is fine. This one is fine. Yeah, no short. This one is fine. Then we have here a coil, 17 ohms. Then we have here another coil, and this one is fine. Yeah, no, everything is looking fine. Here we have a current sensor. Here we have another coil. This coil is fine. This is the input and it's fine. This is a current sensor and it's fine. Here we have that seal. I don't know what to do because it can be normal. Can be. I've seen cases where the battery, especially on Dell laptops, the battery is enabled by the board. So it is possible the battery to be good. But we have to start from somewhere. Okay, let's take the battery out. And now the battery is out. Wait, this is liquid damage. What is this? It's sticky. I mean, I'm not sure if this is from factory. I mean, check here. This is sticky. Do you think the liquid got inside from these vents? Wait, this is a speaker actually. No, that's a fan. Yeah, it's a fan. You know, it looks pretty clean, so I'm not sure what should I say. Okay, let's leave this on one side and let's check about the battery. I mean, this battery is so... the cells are coming out, you can believe that? I mean, here it's a cell. Check that. Kind of like, you know, dodgy. Do not disassemble. This is a serious warning. I mean, not sure if I should take out the cell or the sticker. Okay, we took out the sticker. No, it's no board there, I can't believe. No. So where is the board? Coming out. Plastic clips, yeah. And we have nothing inside. Wait, the board is going down. Check that. There is the BQ chip. Yeah, we have to take this thing out. We have to do a small surgical incision somewhere here. Yeah, like that. And here. Good. And now we can take this out. Yeah, and now we have access to the board, but the problem is no fuse here. So the fuse must be on the other side of the board. And of course we cannot reach it. Or we can. Yeah, check that. There is the fuse. You can see it. Yeah, there somewhere. There is the fuse. I think we can check with the multimeter. Let's do some checks. So the cells, this one, 1.5, lol. 3.2, 3.3, and 3.3. You see, that's why the battery is locked. Yeah, because of this cell, which has 1.5. So plus is here. Okay, let's push some current into this cell. Plus, minus. And the battery is taking 2.6 amps. And the voltage is going up. Good. Let's see if the cell took some voltage. Yeah, we have like 3 volts. 3.3, 3.3, 3.3, yeah, nearly. The plus is here. Just a little bit of current on this one. Yeah. Good. And more current on this one. I can only hope to be the problem with this tablet, only the battery. So the voltage here is 3.2. We need more current. Plus here. The thing is, even if we are doing the cells, the battery is still locked. And we have like 3.3, so all cells are good. Minus and plus, and obviously we have no voltage. I want to check the fuse. Yeah, that's what I want. Okay, so I'm holding the battery under my legs. And I will try to check anything here. So here we have 10 volts. And here we have 10 volts. Okay, the fuse is not blown. Ah, the fuse is good. Okay, so we don't have to take anything out. What we need is to connect the battery to the NLBA and unlock the battery if we can. Okay, so we have the NLBA. Let's bring the program to the screen. So we have the software on the screen. Good. We do have power. Start reading, and I will try to connect the wires. Yeah. So the battery is connected. We have clock data plus and minus. And we can read the battery. Let me make the program bigger. So we can clearly see the battery is locked, but the cells are balanced. You remember we charged that cell. Good. Capacity of the battery, it's empty, and health. Check the health of the battery. This is like brand new battery. You can see the health. So no sure. I mean, check here, the cycle count is 0. So basically this is a brand new product. How you can have a cycle count of 0? Okay, anyway, let's go to reset, power off, reset, power on. This chip is supported, press next, next. Read chip info. And what's the problem here? I mean, not sure, I have no idea, but we have PF status. Check here, PF status, we have an error there, you can see. So what I'm gonna do, I'm gonna unseal the battery. Leave me a comment if you know what is the error on here. I mean, here are a bunch of things. PF status. The fuse is good, you can see here. Yeah, detected. So we unseal, read chip info. Good. Clear chip errors. Okay. Read chip info. And PF status is 00 here, you can see. So now it's fine. Seal. Exit boot. Read chip info. And now we don't have any error. And we have charge FET. Yeah, you can see here on the top. Charging disabled, you can see. Now we have charge FET active, discharge FET active. That means if we are going to the battery info and battery info, read all, the battery is unlocked. So if we are trying now to go to charge and start charging, check that, here here is the current. So the current is going into the battery. You can see the current is going up, the voltage is going up. Yeah, so we just unlocked the battery. Let's wait 5 minutes for the battery to charge. So we left it a little bit on charge. Stop charging. Yeah, we have some voltage into the battery. Capacity just a little bit, but that's fine, that's okay. Let's disable the NLBA. Disconnect. So what do you think? The battery it will work or not? That's my question. We don't need the NLBA anymore, no. Let's bring back the tablet. I mean, a good sign, it will be if the tablet is charging. So plug in the battery is plugged. Plug in the charger. The charger is plugged. Let's wait. It's taking no current. Yeah, that's bad. Pressing the power button. I mean, some things happen when I'm pressing the power button, but it's not charging. Battery voltage. Check on the screen, we have 13.4 and it's going down. Wait, this is warm? Actually, the tablet started. I can feel it warm. Yeah, the tablet is on. That's why the voltage is going down. Oh lol. Wait, one second. Let me plug the screen. So actually, the problem is the charging circuit. The screen is plugged in. Not sure what is this. This is the touch screen? Yeah, probably. So plug in the battery. Pressing the power button. The voltage get dropped to 15.3. Check there. That's mean the tablet started. Yeah, the voltage get dropped. Check there. We have a current limit. Yeah, the tablet started. Yes, it's warm. It is warm. Let's wait for the picture. We have picture. That's crazy. Huh? What do you think about that? Oh lol, actually it's working. I can't believe. Yeah, let me take out the power supply. The meter got reset. It's not working. It's not charging. Nothing. Wow. Pressing the power button and it's going off. Okay, now we know our issue is the PD controller. And it's not the PD controller. It's actually the MOSFET passing the voltage from the charging port to the main power rail. That's the issue. So what I'm gonna do, I'm gonna disconnect the battery. The battery now is repaired. I'm gonna disconnect the screen. The screen is good. And we're gonna focus on the input circuit. Yeah, probably you know already what's the problem. You know the failing MOSFETs from the motherboard? Yeah, it can be. Let's see. Well, only Lenovo was doing this. Now even ASUS. We have to find the PD controller. So there is the USB-C. Here is the Thunderbolt, the data chip. Where is the PD controller? Haha! What I told you. Check that. You can see the chip. Yeah, that's the prick. Yeah. So this chip actually, you know, has a problem from the factory. TPS 65994. Yeah. AD, it's important. So this chip is failing on like every laptop, everything. And yeah, now it's used here. But the thing is, yeah, the thing is, actually, the a lot from this chip is working. Yeah, it's speaking with the AC chip. It's speaking with my charger. So the problem is, it's not enabling these MOSFETs. Yeah, that's the issue. That's the problem. So what I'm gonna do, I'm gonna plug the charger, and we're gonna follow the voltage. So this chip is still doing something. It's still doing like 90% of his job. So the charger, it is plugged in. So we will follow. What do we have here? Here we have 20 volts. You can see, yeah, 20 volts. Here we have nothing. I'm assuming this tablet has one more port. No, I can't see one more port, so I have no idea why. Here we have another row of MOSFETs. I have no idea why. But here we have 20 volts, yeah? Here we have 19.6. And here we have 0. You understand? So the voltage should pass like through the wires, yeah, across with these MOSFETs. But because here we have 20 and here we have 19.6, is because on the gate we have nothing. We have 19.5 and we should have 25 volts. 25 volts, which is coming from this chip. Yeah. So that's the problem with this tablet. The solution. You won't like it. You won't like it. I mean, what options I have? This chip has to be pre-programmed. I can't program this chip. I know it's a guy on our Discord, Mike, has a YouTube channel. He programmed this kind of chips, the PD controllers. But this is not for me. I'm a hardware guy. I'm not good with software. So for me, replacing this chip is no option. The second problem is replacing the chip. I can't really give warranty. Do you think if I replace the chip, it will work for 3 months? Huh? You can't be sure about that. So the only option I have here is bridging the MOSFETs. Now, why these MOSFETs are here on the first place? Well, because it's a second input somewhere. That's the reason why. And not sure where is the second input. Let's try to find the second input. So here we have a USB-C. Not sure what is here. Buttons? Oh. Well, here is some big port, right? Yeah, that's why we have a second row. Yeah, 1 second. Yeah, check here. Yeah, you can see. Wait, maybe this port is working. 1 second. Maybe we don't have to fix it. It is working. 1.7 amps, I can't believe. Now, wait a second. Okay, this is working. The tablet is on right now. Yeah, you're right. So let me show you how it's supposed to work. Yeah. So how it's supposed to work is like that. Yeah, the input is 19.6. Yeah, that's fine because it's taking a lot of current. The output 19.6. The output here 19.6. And on the gate we have 25. Trust me, it is 25. Even if you see OL there. Yeah. So that's how it's supposed to work. So this one is working. So part of this chip is working. Now bridging these two MOSFETs, yeah, I'm still fine. Yeah, the voltage from here, it will not come out on this port. But the voltage from here, it will come out to this port. Yeah, 1.5 amps, and the tablet, it is on. It's proper hot. Of course, on this one, it's not working. So what we are doing? It's tricky because the customer need to not use this port to charge the tablet. This port is covered with some plastic thingy. On the other hand, I mean, one side is still good, but it will gonna fail. Yeah, so again, it's a warranty thingy. Okay, let's do what we start to do. And I will let the customer know to not plug on the same time two USB-Cs. Probably even if he will plug, because one is fine, yeah? So here he can plug anything, and here cannot plug anything. Basically, on one port, he can plug anything, yeah? No, on one port, no, let me say it like that. So on one port, he can plug the charger, only the charger. And on the other port, he can plug any like USB device, and it will be fine. So a little bit of solder. We do have a capacitor here, and that's fine. Yeah, solder there. Here we have some solder. Perfect. Good. Perfect. So what do you think, huh? Proper repair job, right? Yeah, it is. It is. Let's use a little bit of hot glue. Now the good part is because here we have no MOSFETs, it will be no heat. Huh? Yeah, hot glue. Perfect. So what do you think, it will work? That's my question. Let's see. So plug in the charger. It's not working. Wait, what? Why is not working? Wait a second. Wait a second. What happened here? So the main power rail has 19 volts. Wait, so actually my thing, it is working. Then, where is the power button? Pressing the power button, 100 milliamps. Wait 1 second, let's plug the battery, see if it's charging. So the battery is plugged in, plug in the charger. It's not charging. Why is not charging if the main power is present? And the other port, it is working. 3.1 amps, check that, 3.1. Wait a second, 1 second. Did we check the MOSFETs, if they are good? No, huh? No one told me to check the MOSFETs. Dodgy people. Yeah, it is possible to be some MOSFET short circuit detection here. This MOSFET is good. This MOSFET is good. The gate of the MOSFET is good. The MOSFETs are good. So why is not working? This is a protection. Yeah. No, let's check one more time. This is a protection. The circuit is auto-protecting from something. Who put hot glue here? I can't believe. Okay, that's crazy. Hot glue over the solders. Dodgy people. Dodgy technicians. I think I'm gonna speak with the customer. I mean, this tablet, I checked based on the specs and model number of this tablet is like 1,500. And for me, replacing that chip, tricky. I mean, the tablets are already working. That's the problem. The customer can use it like that. So I'm taking a risk, and the risk is ending up with like a dead EC chip or a dead tablet, because that chip is speaking with the EC chip. So I don't think I'm confident going forward replacing that IC when actually the tablet is working. If the tablet is not working on one, on any port, it's not charging, then yeah, it's making sense. Basically, I can't start working on a working device, especially, this expensive. Even the customer asks me, like, it's a brand new job. Okay, so my tablet is working, but only one USB-C port, and I want to fix the second one. I will not take the job just because it's an expensive device and things can go wrong. Anyway, the customer has no reason to not be happy for this repair. We learned few things, yeah. Now we know what is inside, how has to be open and stuff like that. Now you know how to check the battery. This battery has to charge with the power supply, so if it's not charging with the power supply, it is locked. And you've seen where is the PD controller, and pay attention on this port, because not many people knows about this port, just because you have this plastic thingy over the port. Probably that's why the customer didn't know actually he can use the tablet with that port. Okay, so thank you for watching. Like, subscribe if you like the video, and see you on the next one. Bye. And by the way, don't forget, you can find in the description the link for the battery repair software, yeah? Keep in mind. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members-only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.